Good evening, everyone. Today's presentation is about distinctive punctuality, kerosene flour, enriched pasta, and innovative application in foods. Let's start by looking at some papers that I primarily referenced. The first one is pasta fortified with C-glycoside with kerosene flour, inhibitory activity against carbohydrate digesting enzyme. And the second one is caffeine, a new perspective for functional food. So before starting, there's one thing you need to know, what is carrot. Many of you might heard of locust bean gum, thickener. That gum is from this carob tree. Carob tree has been traditionally used to obtain locust bean gum from the seed endosperm that accounts for only 10% of the crop. It is currently used as food additive, and also it can be used as a stabilizer and flavoring and emulsifying agent. Locust bean gum is in great demand, especially for its functional properties, neutral flavor, and toxicological safety. So this carob tree is also called locust tree. Carob is an evergreen tree of Fabaceae family native to the Mediterranean region. It has elongated or curved compressed part of the dark brown color, and it has been cultivated for centuries, especially in Spain, Italy, Portugal, Morocco, and because of its edible fruit, the carob ripe pod can be eaten raw as a sweetmeat due to their high sugar content. Many scrolls, but more often they are used as an animal feed. Owing to their excellent flavoring property, the non-fresh carob pod are utilized in many countries of the Mediterranean area to produce popular beverages, homemade cake, pastries, and some confectioneries. Ground roasted carob pod consists of natural sweeteners commonly employed as the caffeine or theobromine-free cacao and coffee surrogates, and it consists of pod and seeds. There, the seed can be divided in three parts. The three parts are known as hull, endosperm, and germ. This germ is a byproduct of gum production and can be mechanically separated from the gummy endosperm, and the seeds account for 10 to 15% in weight of the carob, and the germ representing 1/3 to half of the seed dry weight. So the carob seed germ flour is a protein-rich edible matrix containing 45 to 55% of protein with a balanced content of essential amino acid and nutritional profile similar to leguminoside, such as soybean. The structural and functional property of carob seed flour protein has investigated. The carob seed flour also contains functionally and nutritionally interesting components, including uh, unsaturated lipid and phospholipid and some phenolic compound. By the virtue of the explosive composition and nutritional properties, capsaicin flour has a potential to be used as an ingredient for special food formulations. However, capsaicin flour is particularly interesting for its polyphenols. The predominant polyphenol of capsaicin flour are apigenin, 6,8-C diglycoside isomers, namely shaftocyte and isoshaftocyte, and other various glycosylated form of apigenin. Flavin C arabinosides are one of the less common classes of flavonoid glycoside occurring in nature. But flavin C arabinose has been detected in a variety of different species, although at much lower concentration than in capsaicin flour. Similar to numerous other polyphenols, certain flavonoids, including apigenin C glycoside, have been recognized for their effective inhibition of enzyme responsible for breaking down carbohydrate, such as alpha amylase and alpha glucose. The salivary and pancreatic alpha amylase isoform catalysts starch degradation into lacto-oligosaccharide, while alpha-glucosidase situated at the brush border membrane of the small interstitial enterocyte with enterocyte monomosaccharides. Since alpha amylase are alpha-glucosid alpha amylase and alpha glucose inhibitor delay glucose absorption and reduce the blood glucose after meal. So they have been suggested as possible alternative to the pharmaceutical treatment or insulin resistant and type 2 diabetes. So in this study, they prepared the pasta on the laboratory scale, incorporating 5 and 10% of capsaicin flour in wheat flour, and assessed the capability of phenol extract from pasta to inhibit porcine pancreatic alpha amylase and intestinal alpha glucosidase, and the effect of incorporating capsaicin flour on the starch digestion. So this is the preparation of pasta. The pasta was prepared by substituting the commercial durum with semolina with 5% and 10% of the capsaicin flour. A control sample consisting of 100% durum with semolina was also prepared for control, and tap water was added with a flour to water ratio with 2.5 to 1 until homogeneous and well-made dough where it was achieved. The dough was manually kneaded for 5 minutes and flattened into 4 millimeter thick sheets and extruded into a spaghetti-like shape, and the raw pasta sample were air-dried for 16 hours. And then 100-gram portion of pasta sample were cooked in 1 liter of boiling water with 1% NaCl, followed by draining and preservation of the cooking water. The cooked pasta sample were weighed to determine water incorporation and promptly utilized for polyphenol extraction experiments. As seen on the right side, the sample utilized in this experiment are denoted by abbreviation for convenience. The raw pasta sample containing 5 and 10% of capsaicin flour will be denoted as R5 and R10 respectively, while their corresponding cooked pasta sample will be labeled as C5 and C10. The pure semolina raw and cooked pasta sample will be referred to as RCTR and CCTR respectively, and the cooking water from the pasta containing 5% and 5% and 10% of capsaicin flour will be identified as W5 and W10. And this is the list of the experiments done in this paper, but due to some time constraint, I will focus on the 3 things. So in this study, they revealed that shaptoside is the most abundant polyphenol in capsaicin flour, while isoshaptoside occur in much lower concentration. The dominant polyphenol of capsaicin flour are depicted in figure 1A, and the peaks at lower retention time have been identified as additional glycosylated apigenin derivative, and the peaks at high retention time are the allyl ester of shaptoside and isoshaptoside. The minor amount of mono-C glycosylated apigenin derivative are also detected in the polyphenol extract of the capsaicin flour. And the HPLC chromatogram presented in figure 1B illustrate the polyphenol extraction obtained from raw pasta sample. The profile of R5 and R10 extract exhibited the predominance of polyphenol from capsaicin flour, whereas RCTR showed no peak of significant intensity. So according to the conventional procedure, the portion of the pasta sample underwent cooking in boiling water. So the concerns regarding the thermal-induced decomposition or some partial leaching of polyphenol during cooking, potentially limiting the health-promoting properties of polyphenol-fortified pasta, prompted a primary investigation. So they examined the persistence of capsaicin flour polyphenol in cooked pasta, whose name is C5 and C10, which is after drain. So in comparison to their non-cooked pasta sample named R5 and R10 using HPLC. So this figure 2 displays the HPLC analysis of extract from CCTR, C5, and C10. And figure 3, in C10 pasta, shaptoside exhibited a reduction of 29.7 plus or minus 0.5% compared to R10, indicating that more than 70% of its original content was retained in pasta after cooking extractable form. And as you can see in the figure 4, the analysis of the freeze-dried water resulting from cooking C10, which means W10, revealed that about 12.1% of side had been discharged, suggesting that approximately 17.6% of its original content might have decomposed or chemically bound to some starch matrix like starch matrix of the pasta, and it was no longer extractable. And in cooked pasta, a slight relative reduction of the species at higher glycosylation degree was observed. So due to their increased water solubility, which corresponded to their slight relative increment in cooking water. So aside from that, the qualitative HPLC profile of polyphenol extract from cooked and raw pasta were substantially conserved, indicating that the degree of retention in the pasta was similar for the various polyphenol compounds. So the total polyphenol were determined in raw and cooked pasta sample in cooking water using the polycyclic spectral photometry assay as reported in table 1. So this assay confirmed that scarce-season flour is a polyphenol-rich matrix. So about nearly 82% of extractable polyphenols were retained in C10 after cooking, which is roughly in agreement with the HPLC-based germination, taking into account the possibility that the polyphysial culture assay can be biased as a number of interfering compounds like reducing sugar or some amino acid. So based on polyphysial culture assay, the concentration of polyphenol in RCTR was relatively high, whereas only a few peaks of relatively low intensity were detected in HPLC chromatogram of the relevant extract. A value of 71.1% of inhibition. And pure side and iso side both at 0.1 millimole exhibited 50.5 and 54.8% inhibition, respectively. And the alpha glucose inhibition of tenfold diluted carboxygen flour inhibitory potential tenfold diluted carboxygen flour extract was 57.4%. These values indicate a remarkable inhibitory potential of alpha-gene like glycoside against interstitial alpha glucostase, although lower than archibus, a positive control in line with the previous observation. So similar to the alpha amylase inhibition, the introduction of carboxygen flour in pasta induced a reduction of the alpha glucostase activity with reduced effect for the extract from cooked pasta sample compared to the raw one, and most likely due to partial loss of carboxygen flour polyphenol into the cooking water. So to sum up, the primary polyphenol present in carboxygen flour are shaptoside and isoshaptoside. And shaptoside consists of the majority of polyphenolic content in carboxygen flour, whereas isoshaptoside is present in significantly lower amounts. The extract from raw pasta inhibits DPPH radical inhibition than cooked pasta with R10 and C10 exhibiting stronger inhibitory activity than R5 and C5. Additionally, R5 and C5 demonstrated the more potent antioxidant activity than the respective all with a control pasta sample, and apigenin 6,8-C-diglycoside inhibit porcine alpha amylase and a small interstitial alpha glucostase, and the extract from pasta fortified with 5 or 10% of carboxygen flour inhibited alpha amylase and alpha glucostase. So adding the 3 experiments that I didn't mention, the conclusion is like this. So in this study, it is demonstrated that carboxygen flour flavonoids significantly inhibited porcine pancreatic alpha amylase and small interstitial alpha glucostase, and it is selected as a model of human carbohydrate digesting enzyme. And the presence of 5 and 10% capsaicin flour in pasta delays starch digestion, and the enzyme inhibiting properties are substantially retained after pasta cooking. Therefore, a partial replacement of wheat flour with capsaicin flour could be represent a dietary strategy for reducing the onset of insulin resistance and type 2 diabetes. And in addition, capsaicin flour protein are high in lysine, so it can compensate for the deficiency of typical cereals such as wheat, enabling the preparation of high nutritional value pasta or other products. And capsaicin flour is the byproduct resulting from the agro-industrial processing of underutilized and neglected crops, so which can be grown in semi-dry and less volatile soils. So extensive use of capsaicin flour with the criteria of sustainability. These are some other two papers that I looked for to explore some topic further. So the first study looked into evaluation of muffin incorporating care. They say the observed characteristic of this muffin include high water activity, high total phenolic content, and high antioxidant activity, high content of phytosterol and genistein. And moving on to the second study, the focus shifted to incorporation of carrot in yogurt production, aiming to assess the impact of the product's characteristic. The yogurt enriched with carrot exhibited a raspberry increase in both fiber content and sweetness. So this suggests that the addition of carrot not only enhances the nutritional profile by introducing high fiber content, but also contribute to the overall sweetness of the yogurt. So in summary, these studies highlight the adaptability of carrot in food application, demonstrating its capacity to improve flavor, nutritional content, and overall appeal in both baked goods and dairy products. These are the references I've realized, and with that, I would like to conclude my presentation. Thank you.